The recording on the first video is a little bit off. Please do excuse that. Okay, so before we go into the practical experiments, or things that I want to show you, first let's talk about the triboelectric series. Now, this is pretty much, when I saw this, I was like, oh, I get it now. That's how orgone works. If anyone hasn't looked into Wilhelm Reich and his orgone generator, from what I understand, he had like a shed, kind of like a box made of wood, I think, and inside it was layered with, I believe it was steel wool and actual like animal wool. This would be like a positive and a negative material, and people would sit inside of it and they would heal, they would get energy, and they would feel good. And for a while I really thought about this, and eventually when I looked into like electrostatics, I started to understand that, oh wow, these orgone generators are actually pretty much some kind of like a natural energy generators, right? It almost works similarly to the way that a battery works, with layers of insulating and conducting materials, if you want to think about it that way. You know, metal obviously being a conducting material, and something like a plastic or paper or some kind of like a hair or wool being an insulative material, right? Well, anyway, triboelectric series, we have materials going from essentially positive to negative. Here's a little bit of an easier one to understand. You can see, so it's not a hard thing, unless we're talking about something like glass or Teflon, which Teflon is an absolute negative here, and glass is an absolute positive. Interesting, of course, because the idea of glass, quartz is glass, or glass is quartz glass, right? Of course, it can be different forms of glass, but you think a magician would have a glass or a crystal on the end of their staff, or they would have a crystal ball. Why? If we look at the triboelectric series, it's because it gives electricity. Another interesting thing is that the pyramids were supposedly coated in mica before they got raided. And mica being like a sheet material, a glassy kind of sheet material that assumingly would give electricity. Now this one says, if two materials rub together, the one that is higher in the series will give up electrons and become more positive. And let me explain that. Electrons, or what you can just think of as electricity, right? Because we don't have to quantize everything, is negative, at least in like particle science, I believe. You have the neutron, which is neutral, the electron, which is negative, and the whatever they call the positron, proton, which is positive. So it's like a negatron, a positron, and a neutron, or a negative, a positive, and a neutral. And these materials, which we can see leather, rabbit fur, glass, human hair, nylon, wool, fur, lead, silk, aluminium, paper, copper, steel, wood, and amber are all more positive, right? And then we have the hard rubber, nickel, copper, brass, silver, gold, platinum, polyester, styrene, saran wrap, which is plastic wrap, polyurethane, polyethylene, polypropylene, silicon, Teflon. These are the more negative ones, and of course we can notice a trend, which is that the negative ones usually are metallic or of unnatural polymers. There are very few polymers which are positive, FYI, and some metals which are positive, like aluminium, but usually the ones that are negative are metals and plastics, and usually the ones that are positive are natural materials or glass. Things like basically furs and hairs and all these kinds of things, or glass, right? So here we have the spectrum. So this is how, when people rub balloons against their hair, and then the hair stands up and the balloon becomes charged, or the rubbing a PVC pipe with some fur, and then you touch someone with the pipe and it zaps them, right? Or when people would rub amber. This is how all this stuff works, essentially, is that the positive material is giving its electricity to the negative material. The negative material is becoming electrically charged, And then when it touches something like a person or some metal or something, you get that little zap. That's the kind of basic hypothesis. And of course, the strong electrostatics can cause levitation in things. You know, when you have the balloon, which is charged, the hair wants to be attracted by it. You're literally levitating hair. It's a non-metallic levitation, because we all know magnets, which are metallic, can levitate. You know, they can push and pull and, you know, have that force. And there's little toys where you can have magnets just kind of hovering. This is a non-metallic or levitation force, essentially, just through electrostatics. Anyway, let's get on to the video experiment. Okay, so firstly I have these two little pieces here, and what these things are, it's a wire attached to a piece of foil. It's a piece of paper, and it's the whole thing is taped with this plastic tape that you can buy from the store here, and I've got two of them. Just to give a better explanation, I've essentially created like a sheet of tape over the top to fully cover the foil. That's the idea. I believe the explanation of how they work is because so for some reason, when you rub them, it produces a electrical charge. Rub the paper against the tape, it will actually so the paper is giving energy to the tape. The paper is a positive, the tape is a negative, and the foil in the middle is essentially just a collection area for electricity. That's all the foil is doing, I think. You could create ones that use foil as like the negative, but the foil and the wire is getting the energy from the tape and the paper, I think. So here we have our voltmeter, and I'm going to turn it on AC, on 20 AC. And we're going to connect this. The negative, I'll do the bottom. I don't think it actually really matters because it's AC. But and for the positive, I'll do the top. Okay, so we've got it connected. And now when I rub it, look at the meter here. Look at that. We nearly got a volt AC. And I know I can, look at that. See, about 4 volts AC. 5, 6, 7. 7 volts AC, which means basically I've got like 3.5 positive and 3.5 negative. This is how a Van de Graaff machine essentially works, but you have like the belt continuously producing that. And if we go like that, look at that. So you can tap it, for example, you can rub it. You can maybe rub them both. It seems the most effective one is just to go really hard and rub it like that, or to tap it like that. And look at that, you're getting an AC voltage. Now if we go to DC, we do actually get we're getting negative voltage. Interesting. We do get a voltage. If I go really hard, I can nearly get about it's negative though. If I do it the opposite way, that's negative as well. Or like that. I wonder if I flip them over, do I get a... Oh, look at that. Interesting. It's very, very small though. Now it's only in millicurrent, so we're not getting much, but I'll try to see if I can light up an LED. Now can we get this working? No, it doesn't look like it. Nothing. I've seen in another video someone was able to get them to light up, but I don't seem to be able to get them to light up. Interesting things. Next thing, we have 2 interesting little pieces of equipment. Now this is just taking a spice jar. It's good because it's see-through, and it's got the lid, and we cut a hole in the lid, and then I put a piece of wire, and I just coiled it there, and we've kind of made like a hook. And then we have these 2 pieces of foil. You can see here, just 2 pieces of foil with a hole in them. And they're kind of dangling like a set of keychains, right? It's called a electroscope, I think. It's basically a static meter. And when you put something that's electrostatic near it, what will happen is that you will separate. Like if you get a balloon and you rub it on your hair and you get the balloon there, it'll go boom, or it'll woo, or fly around. Like next one, I don't know if I'll be able to show this on camera because it's really big. But this is a bottle, a 1 liter bottle full of water, and I've got some aluminium foil taped here. It's not connected electrically to anything, and then we have a nail, like an iron or a steel nail in there, and there's salty water in there. This is called a Leyden jar, and the purpose of the Leyden jar is to store, I think it stores charge in the water, and when you connect these together, it'll zap. You'll get a little zap. So once you connect these and these, and you can touch them and you can get a zap off it. So you just have to keep touching the top with some kind of electrostatic thing, you know, somehow, and then when you touch that, and then it'll go zap. So I'll show you these two. And I want to test something else out as well, which is I want to see if I can get an AC current from electrostatic. I don't know if it'll work, but we're just gonna, similar to like an antenna, if you were to have an antenna in the sky and to collect electrostatic current. I don't know if it'll work, but we'll see. And of course I've got some gloves. You can hear it already, and what I'm gonna look at when I put it near, do you see the, here, I'll get this. See how it's kind of moving it? Okay, I've got it up there. I want to get that like ionic field. Look at that, see that? Not touching it, but it's, oh, yep, there we go, see? Alas, you know, you did see it move. It's actually a lot easier with a balloon. Now, can we get an AC voltage off this at all? Let's see. Yes, we are. So that's like acting as an antenna, and then, okay, it's pretty much transmitting. It's nearly transmitting as much DC to AC. I mean, technically, I guess this is an AC transmitter. I'm not exactly sure. Point being, the voltmeter was on about 1.5 volts DC, and I think that was converted to AC. So we were actually picking up an AC voltage. Now, are we picking up much amperage? That's an interesting thing. I want to test that. Tiny amount of amperage, actually. That's actually pretty cool. If we go, yeah, only a tiny amount. Because if you know anything about atmospheric electricity, it is really low amperage. Like really low amperage. So I had this idea of using a bunch of transformers to raise, because it's super high voltage, but it's super low amperage, similar to the power lines actually, which is how they get low resistance. So I had an idea of just using a bunch of transformers to boost the current of the atmospheric power. Let's test out the jar. What I'm going to do to charge it is just to kind of hold it like here. You can see it's actually, oh, it's hard to, it's like electricity's going from this to the jar. Oh, now I'll turn it off. What we'll do is we'll get one of these, and I'll go touch to here, and then watch the head of the, oh, you heard it but didn't really see it. Made a little pop or a little zapping sound. I couldn't really get this one to work on camera, but it's an interesting thing if you want to look up Leyden jars and make one yourself. Final one, I want to show you the ionic field
in the dark. I think that'd be kind of cool. Okay, now we're in the dark. Well, technically, I just closed the blinds. And can you see that? Tiny bit. Ooh, I can see it. It's very... It's very hard to see on this. Ooh, wow. Oh, yeah, no. Unfortunately, it's very hard to see. So I could see there's a little glow on the ends of each of these, and there's also like a web where you get them close enough. And but it was kind of hard to see on the camera. When I edit it, I'll see if I can see if I can see it. But otherwise, I'll summarize things on the computer maybe. For anyone who is interested in it, I got a bit of Shungite. It's really cheap. You can get the powder or the stone off AliExpress for like a couple bucks. And it turns out it draws. I tried to make a circuit with it and it didn't really end up working. I know there's those graphite circuits that people have, but anyway, this stone is, well, technically it's pretty much just graphite. I mean, I literally think it is graphite just from like Russia. If you look at it, it looks like graphite. It draws like graphite. Did I get sold graphite? Is Shungite just graphite? I don't know. Either way, it doesn't really matter. Which is made out of carbon. And if you know about this stone, it gets your handle. If you know about it, it was popular around when like all of the scamdemic stuff happened, because supposedly it had like anti-EMF properties and such. And I mean, it feels like it, I guess. You know, if I hold this or I keep it in my hand, in my pocket, it's kind of like lead. Like, it's similar in quality to lead, where it's like, you know, anti-anxiety, anti-EMF, anti, like, you know, just excess energy, and it kind of makes you feel like more relaxed and more like stable and just, I don't know, just like peaceful. It soothes the root, you know, the bowels and the root and the tailbone, like the coccyx region. It soothes all of that, and I guess like the legs, yeah. So if you're interested in a stone like that, yeah, Shungite, or you could literally just buy graphite. I mean, I'm pretty sure it's the same essentially. I mean, this one has certain supposedly heavy metals in it, which I think personally, I think it improves the like quality and effect of it, because that's kind of what, you know, like they say lead and cadmium and all that. You know, again, once people stop demonizing lead and other heavy metals and actually figure out that they're useful, then, you know, maybe we can have a proper discussion and a proper, you know, it's like that mineral, that shilajit. People were, you know, they wanted to get shilajit without all of like the heavy metals, but it's like, hey, maybe they're actually doing something. Whatever, that's just my opinion. But anyway, Shungite, so interesting stone.
Going on a little more, if we look at, for example, if we look at the word ether, I believe in Latin, ether there, or air, it relates to air, and it has words like pure air, upper world, upper, and it's really talking about the upper air, right? The upper world. This blue stuff, I think, is what we call, this is like a condensation of ether. And of course, ether is debatable for how you want to, you know, define the word, because it can be used to define space, which, you know, like three-dimensional space, which everything exists within, right? Because ultimately, you know, electromagnetism needs a medium, right? And space is the medium for that, you would assume, because it, you know, just kind of exists. But the word ether was used to kind of describe the upper sky. And we can think of this in the four elemental system as the fire element. You know, the earth element obviously is the dirt, the ground, the rocks beneath our feet. The water is the seas, the lakes, you know, all that. The air, of course, is, you know, where we can put our hands, where the trees grow, the birds fly. And then the fourth of fire, or you can think, you know, vaguely, ether is that blue ionosphere glow, and that's like an area or a realm, a space of immense electrostatic charge. It's immensely charged with energy, right? And of course you can then break things up into 5 and have like the maybe even a higher level, you can call that ether or whatever. So it's not really, we're not really trying to debate the word, but what I'm trying to bring into the idea is that, you know, there's so much energy in the world. Like the same way that underground there is like infinite amounts of minerals, basically, you know, not actually infinite, but seemingly infinite amounts of minerals which you can use for whatever you want. In the sky there is seemingly infinite amounts of this electrostatic energy which we can use for whatever we want. Now here is a picture of the Reich orgone accumulator box, and this one uses fiberglass as its organic. Now the idea was to have an organic and an inorganic material. So people would use wood, fiberglass, they would use wool, and you can make these yourself. They have interesting properties, feelings to them, and then they'll have the inorganic as steel wool or aluminium or, you know, whatever metals you can get your hands on, right? And you just can keep wrapping things, and what it creates is a what you call like a energy accumulator, or like a static accumulator, or see, it's a negative and a positive, because the earth, I believe the earth it gives, you know, it grounds, right? These would probably have some kind of, depending on the materials you use, would have either a grounding or a more stimulating effect, I assume, which you'll have to think about when you're building this kinds of stuff. But you can see the kind of idea of the positive and the negative, where the ambient energy from the air and also the ambient energy from the earth, you know, depending if you ground it or not, I guess passively it just kind of would be grounded if it's on the ground, right? Anyway, you would assume that it is collecting these things just passively. So here we have a modern piece of orgonite, which it's essentially just resin, like an epoxy resin, right? And or fiberglass resin, and you've got like metal shavings and crystals and such inside of there. You can make these. They do have a certain feeling to them. It's like almost like a moldavite, which is a very strong crystal. It has that like strong feeling. You do have to be careful what materials you use for them, because they are strong. They are powerful, these things. And it will have an effect on your body, your room, your house, your life, potentially even your electronics. So you don't want to use materials that, you know, is not good for that. You know, if you need something relaxing, then use something relaxing. If you need something stimulating, then use something stimulating. And just be aware that it does have an effect on you. And then finally we have another picture, which is just wool blankets and steel wool layered, and seemingly a pillowcase this is. So I think I'll do another video eventually when we work more on like orgonite and all that stuff, do some tests, and I'll show you that one interesting thing that I made a little like orgone generator and hooked it up to water, and it produced this white crystalline substance, which is very fascinating. So hopefully we can get that to work and I can show you that. But anyway, I really just wanted to, you know, show you a little of this, because I think maybe now you have a better idea of the triboelectric series, and you can kind of understand that the triboelectric series is probably the scientific principle, and things like electrostatics and also the Earth's grounding. Here we go. This flow of electrons is known as the global atmospheric electric circuit, and is driven by the transfer of charge between the Earth's surface and the upper atmosphere. The Earth's surface is typically negatively charged due to the presence of negatively charged ions, such as chloride ions that are present in the soil and groundwater. The upper atmosphere, on the other hand, is typically positively charged due to the presence of positively charged ions, such as oxygen, that are created by the ionization of air molecules, by cosmic rays and other sources of radiation. So essentially the things like the sun and stars and such ionize the what you call the ether, the ionosphere, I guess. You would assume, I guess if you follow like natural harmony, you'd think the air is positive and the earth is negative. And there's some kind of like a harmonious flow, like a cycle. There's be some kind of electrical cycle, assumingly, between them. So anyway, we will figure out more of this sometime later. So of course, I hope you liked the video. Feel free to check the links in the description for social commercial stuff, and have a nice day.